Hello and welcome to your go-to destination for big data cloud tutorials. In today's video, we are diving into the architecture of one of the most powerful storage systems in the big data world, which is HDFS, Hadoop Distributed File System. Let's begin with the basics. What is HDFS? As its name stands for Hadoop Distributed File System, and it is the backbone of Hadoop data store layer. It is the storage system used by Hadoop to store big data across many computers. Think of it as a special kind of file system that can store huge amounts of data like petabytes in a safe, reliable, and faster way. HDFS follows a master slave architecture, which means it has a master system and many slave systems working together. Let's move to HDFS architecture and its components. So as we have discussed before, HDFS architecture is master slave model. It primarily has three components. Number one, name node, the master. Number two, data node, the slaves. And number three, secondary name node, which is helper to the name node. So these are the main three components we need to remember as part of HDFS architecture. So if you see, this is the overall architecture of HDFS as per Apache Hadoop.org reference. So we have no name node, that is a master that has metadata and which is nothing but name, replicas, etc. And it has data nodes. So the client can read data using name node from the data nodes and then other replication of the same data nodes we have, and each data node has several blocks. So there are couple of racks, each rack containing multiple data nodes. The client can read and write from one data node to another data node. So let's begin with name node. So the name node is the heart of HDFS, which is a master in this model. This is also a computer. Let's say this is a master computer of the overall system. And this name node stores metadata, that is information about file names, file permissions, directory structure, and most importantly, the block locations for each file. But here is the catch, it does not store the actual data. It just knows where the data blocks are stored. So as we have seen, name node is the master, stores all metadata, manages file system namespace, keeps a track of blocks and their locations. No actual data is stored in the name node. So that's all about master name node. Let's discuss about the other components. The second one, data nodes. So where the data actually is stored in HDFS. Data nodes are the real workers of the system. They actually store the blocks of the data and report back to the name node at regular intervals. These are running on commodity hardware, and if one fails, there is no need to worry. HDFS is built to handle that kind of failures. So as we discussed about data nodes, it has actual data blocks, send, heartbeat, and block reports to name node, run on commodity hardware, and fault tolerant. Our third component, which is secondary name node, the checkpoint helper, which is contrary to popular belief, the secondary name node is not a backup name node. It performs periodic checkpoints by merging the name nodes in memory metadata with the edit logs to reduce name node restart time. So no, it is a name node is a basically to perform periodic checkpoints. It is not backup as its name suggests. So periodically merges file system image and edit logs. So if you get a question like which part or which component merges file system image and edit logs, then your answer must be it is either secondary name node or you can say the checkpoint helper also. And the third one helps reduce name node restart time. It is specifically built for the checkpoint. And next is how the data is stored in HDFS. When a file is uploaded, HDFS splits it into blocks which sizes basically 128 megabytes or 256 megabytes in size. So first point to remember, files split into blocks of 128 or 256 MB of sizes. These blocks are then replicated by default 3 copies and distributed across the different data nodes so that it ensures fault tolerance. The name node keeps a map of which block is on which data node. So as a master, it contains all the information about the block data stored in all data nodes within the cluster. So that is how the name node manages block mapping. The next important topic as part of HDFS is fault tolerance and high availability. One of the biggest strengths that HDFS is first is fault tolerance. If a data node goes down, HDFS can read from a replica stored on another node. So as we have seen before, Each block will have 3 replicas. So we can read it whenever there is one data node goes down. If the name node fails, a backup from the secondary name node can help restoring it. Through newer Hadoop versions also support high availability of name nodes. So let's summarize the key features of HDFS. One is its high fault tolerance. Number two, scalable to thousands of nodes. Number three is optimized for large files. Number four, write once and read many times model. And fifth, data quality, data locality for efficient processing. So who does it? By master, which is nothing but name node. So overall, name node stores metadata, data node store data blocks, files are split and replicated, secondary name node handles checkpointing. So this is all about HDFS architecture in brief. Thanks for watching, and remember, data drives decisions